one. This is the last part. Okay, this is the last part of the vector value functions. And normally, if you go to the partial question, you will see this one curvature portion. C2, 0. On the right, you have -1 plus C2.
Oh, okay.
This one equals to 0. Normally, you will have one. So normally, one question, the last question from final plan, it will be divided into few subs, and normally you will see this binomial curvature portion, this kind of things. Okay, actually, to get the unit binomial vector, you need the unit tangent and unit normal vector. Okay, because the n and t is formed the t. Okay, the binomial vector is t. And with the b, we can get the curvature. Okay, and then we can get the portion. The same, they come in the package. You need to know starting from the tangent, normal vector, and then binomial vector. Then we can proceed to the curvature and the portion. Everything is about the computation. You have to compute all this by using the given formula. But of course, you have to understand what it means by the tangent vector, normal vector, binomial vector, what it means by the curvature and portion, because you need to interpret something. Okay. Okay, this one. Okay. You look at the curvature. So what is the curvature? If you look at the sentence, the curvature of C. Okay, C is this curve. C is a curve. The curvature of the curve at a given point. Okay, we can have a lot of points on the curve. So at every single point, it has a curvature. And that curvature, it measures how quickly the curve changes at that point. Okay, so this one, the curvature, it doesn't change much because this is quite flat. Okay, but here, the direction of the tangent vector, it changed from this into this into this. So the curvature, it changed. Okay. From the curvature, we know that the tangent vector is changed fast at this point. Okay. So tangent vector, it changed the direction slowly when the curve C bends a bit, as shown in the first 2 points. So these two, the tangent vector, it just bends a little bit. Okay, just like when we drive on a straight road, we don't really turn our styling, okay, much. Just turn a little bit, okay, rotate a little bit. So this one at these 2 points, these first 2 points, the tangent vector, it doesn't change the direction much. But when C twists more sharply, for example, at this 3rd point, the tangent vector, it changes the direction more quickly. Okay. Then we have a higher curvature at this point. Okay, so to compute for the curvature, this is the formula. Okay, this is the formula. So you see, to get this one, this curvature, the name of this Greek symbol is kappa, K-A-P-P-A, kappa. Okay, kappa represents the curvature, and the curvature is the magnitude. You see, magnitude. So when it comes to the magnitude, that means positive value. Okay, because it's just a magnitude. The magnitude of the rate of change of the tangent vector with respect to the arc length. Okay, so this one. So if you look at the formula, you have to compute, if you are given RT, you have to compute the R prime, magnitude of R prime. You have to compute for the T, then only you can get the T prime, and then the magnitude of T prime, right? So you have to do step by step. Okay, you are given RT, you have to compute this. So you have to find for R prime, magnitude of R prime, then T prime, magnitude of T prime. Then only you get the kappa, the curvature. Okay, I go straight to this one. Okay, what it means by the curvature of plane curves and also in space. Okay, so we look at the plane curves first. Plane curves, that means we have a plane, okay, we have a plane and we have the curve on the plane. A curve lies on the plane. That is plane curve. Okay, so this kind of curvature, okay, look at this one. Okay, so this is the plane, and this curve lies on the plane, the planar plane. So we know that the tangent vector, it will always point to the motion of, to the direction of the motion. So if you look at this red color arrow, this means we know that the particle moves from this point to this point. Okay, because tangent vector, it will always point into the direction of the motion. Okay, and now we have the normal vector. Okay, the normal vector, okay, you have to imagine you are walking from this point to this point. When you are walking, your normal vector will be on your left hand side. You stretch out your left hand, okay, 90 degrees. You are walking to the direction, okay, you are walking to the direction, but this is your normal vector. Okay, that's why you have this blue color normal vector, which is always point to the left because it is on your left hand side. Okay, ahead is your direction of motion, which is the tangent vector. Okay, so you see at this point, okay, we have the oscillating circle. Okay, oscillating circle means at every single point, actually we can have an oscillating circle. So at this point, this circle means the point on this curve, it has the same curvature with that circle. Okay, the curvature of this circle, okay, is the same as this point. So if you have a point here, let's say we want to sketch curvature, let's sketch on the wall. Then I want you to understand what is the oscillating circle. Okay, let's say at this point, your circle of the oscillating circle, it will be this one. Okay, let's say you have. So at this point, the oscillating circle is smaller. Okay, because for oscillating circle, okay, the curvature at every single point is the same. Okay, for a circle, at every single point, the curvature is the same. So for this, okay, let's say the curvature is 1. This means at this point, if we have this as the oscillating circle, that means at this point, the curvature is 1. This is what it means. Okay, so at this point, your curvature will be here. Okay, when the tangent vector is pushed fast, okay, your oscillating circle will be smaller. Okay, if it bends a little bit, if it only bends a little bit, the oscillating circle will be very big. Okay, so remember this oscillating circle, we have the radius of oscillating circle, radius. The bigger is the radius, the smaller is the curvature. Okay, this one, the curvature is higher at this point. Okay, the curvature is higher because the curvature is the magnitude of the rate of change of tangent vector. Okay, so this one curvature is higher, this one curvature is lower, but when we say, when we talk about the radius of the oscillating circle, radius of oscillating circle is inversely proportional to the curvature. When this is, when curvature, when the radius is larger, the curvature is smaller. Okay, now back to slide. Okay, in the plane curve, the sign, okay, the sign of curvature. Okay, remember this curvature. It has only plus and minus sign when you have a plane curve. Okay, when you have a plane curve, okay, your curvature is either positive or negative, okay, or zero, okay, positive, negative, or zero for a plane curve. If this curve is in space, in 3D, in space, your curvature, it will always be non-negative. Non-negative means starting from 0 up to the positive, up to infinity. Okay. So only when you have a plane curve, then you will see a plus or minus curvature. Otherwise, in 3D, you have only non-negative. Non-negative means starting from 0 up to the positive infinity. Okay. So the sign of curvature, okay, it indicates the direction of rotation. It's the direction of rotation of the tangent vector. So here, these few points, your tangent vector, it turns to the right. It turns to the right. So when the tangent vector, it rotates in counterclockwise. Here it turns to the right or left. Okay. Normally we use the term counterclockwise or clockwise. Clockwise means it follows the clock direction. Counterclockwise, that means the other way around. Okay. So when the T rotates in counterclockwise, this is counterclockwise. It gives a positive curvature. See, this is a positive curvature when it rotates in counterclockwise direction. And here, this is clockwise direction. Okay, clockwise direction. So your curvature is negative. Okay. Next one. Okay, when you have a line, okay, this one, when you have a line, that means at the point of W, you have zero curvature. Okay, when you see curvature equals to 0, that means it must be a line. Okay, based on the rotation direction, see, this is in clockwise direction. Okay, the tangent vector, see, at this point, it points to this direction. This one points to this. This one points to this. So it points in this clockwise direction. Clockwise direction means the curvature is negative. Based on the rotation direction, curvature at point U is negative. Okay, and here this is anti-clockwise. Okay, anti-clockwise direction. So at this point, the curvature is positive. Any question? Do you get what I mean? Positive, negative, clockwise, anti-clockwise. Okay, clockwise, that means follow the direction of the clock. That is clockwise. The other one is anti-clockwise. Okay, this one I've already explained the radius of curvature. Okay, the radius of the oscillating circle, or we call it as radius of curvature. So the radius of curvature is inversely proportional to the curvature. Okay, so this one, radius equals to 1 over kappa. Okay, curvature. So the bigger is the curvature, the smaller is the radius. Okay, and curvature at point U. Okay, at point U and point B. The curvature at here is higher than this. The curvature at point U is higher than the curvature at B. Okay, you have to remember the curvature is the rate of change of tangent vector. Okay, when the direction is changed faster, that means the curvature is higher. Okay. Okay. Okay, now we look at the curvature in space. Okay, in space means if I sketch a curve on a wall, that is a plane curve. But when there's a particle, it moves from this point up to this point and goes to the floor and then goes to the whiteboard. That is in space. The particle moves in space. Okay, so the trail which is passed by the particle is called the space curve. Okay, it trail, okay, follow a space curve. Okay, so now when we have a space curve, okay, we can calculate for the curvature as well. It's just that your curvature must be non-negative. That means 0, okay, it can be 0, okay, but it won't be negative value. Okay, everything must be non-negative. Why we say non-negative instead of positive? Because 0 is not positive and 0 is also not negative. But for this case, 0 is included. So we can't 0 is not positive. So if we say positive, okay, always positive, it means 0 is not included. Okay, that's why we use the term non-negative. Okay, so for a moving particle with unit speed along a space curve, curvature is the magnitude of its acceleration. Okay, so in a space curve, tangent vector, okay, it is also points to the moving direction. Okay, and the normal vector points to the inner side of the curve. Okay, inner side. So if the inner side, what I mean by inner side, let's say this is a space curve. Okay, this is not lying on the space. This is not lying on the plane curve space. So this is the inner part. This is the inner part. Okay, that is meant by the inner side of the curve. So your normal vector, it will always point to the inner side. This is different from the planar curve. The planar curve, it can point into or point into the circle or opposite, okay, outside of the circle, right? But for the space curve, it will always point into the inner side of the curve. Okay, that's the difference between the plane curve and space curve on the curvature. Okay, now we look at the calculation. Okay, the computation of the curvature. So this is the formula, and you are given R. So we have to find for the R prime, magnitude of R prime. You have to compute the unit tangent vector, then T prime, then magnitude of T prime. Then only you can compute for your curvature. Okay, you have already go through all this. Okay, in this course you have learned all this. So it shouldn't be a problem for you to get a curvature. Okay, it's just that you don't make any mistakes here, then you will get the correct answer. Okay, just compute according to the formula. Okay, this is another example. Okay, this is another formula. You have two formulas for curvature. So when to use this one, when to use this, it depends. Actually, both, you can use any of the formula, you will get the same answer. It's just that under some situation, this one is easier. Under some situation, this one is easier. Okay, so which one is easier? Okay, remember when your RT, you have the cos and sine function. It's very simple for you to get the magnitude of R prime, right? Okay, so magnitude of R prime. So if your magnitude of R prime is simple, so your T will be simple, T prime simple, magnitude of T prime also simple. Okay, there's no issue. Okay, so this kind of question, you have no issue if you use this formula. But if your RT is something like this, remember this? If your RT is something like this, there is no sine and cos. It will be harder for you to get the R prime magnitude, right? Then your T will be complex. Your T prime will even complex, and you still need to find for the magnitude of T prime. So in that case, we would prefer to use this. Because if you look at this formula, we just need to find R prime and R double prime. Just up to R double prime. We don't have to find for T. It's just that we need to find the cross product and the magnitude of the cross product. So as a conclusion, if your question RT is something like this, or something like this, just use this formula. Okay, you can use this formula or this one, no issue. You can use any, okay, you can use any formula. But if your question is something like this, I will suggest you to follow this formula. Okay. And now we're back to the example. This one, I think complicated shouldn't be a problem to you. Okay, now we look at this new formula. Okay, if you use this new formula, okay, you just need to compute R prime, R double prime. And then you need the magnitude of R prime for this. This is magnitude of R prime, then you need to give a cube. Okay, so we need to find for this one, which is 8, and then 8 to the power of 3. Okay, then, okay, this one, for the nominator, you have to find the cross product first. So R prime cross with R double prime. Okay, so you have R prime, you have R double prime, you just find for the cross product. Find for the cross product, then find for the magnitude. Okay, got it? Then you just put it into the given formula, you will get the answer. Okay. Okay, let's have a try. Okay, have a try to find for this curvature. So by using this given formula, you have to find for R prime, magnitude of R prime. P is R prime over magnitude of R prime. Then find for P prime, and then magnitude of P prime. Then you will get information. Magnitude of P prime divided by magnitude of R prime. Okay, try to compute this. If you have a time by attendance. One the balance number one to equals 2. Do you get the 1/8?
Yes.
16 and 15. Magnitude of S1 over magnitude of R prime, which is 8. For number 2, you have to use this formula. Okay, the one given inside. So you have to compute for R prime, R double prime, the cross product, and the magnitude of the cross product, and also the magnitude of the R prime. Okay, you have to know what you need to compute. Compute for R prime, magnitude of R prime, and R double prime. Can I write this up? Have we done? R double prime and R prime plus R double prime and the magnitude of the cross product and the measure. Okay. For the cross product, to get the component function of I, cover the one with that contains I. Okay, cover I is here, cover the row and column AB minus BC. AB, so -16 cos square T. AB minus BC, so minus 16 sine square T. This is component of I. Then do not forget about the minus for the component function of J. Okay, the minus. Okay, cover the row of J and column of J, AB minus BC. The negative 12 cos T. This is for J. AB minus BC. Then plus the component function of K. So just cover the row of K and the column of K. AB minus BC. So AB, you get negative 12 sine T. Okay. So this one you just simplify, factorize negative 16, you get cos square T plus sine square T, which is 1. So you have only negative 16. And here you have minus minus, you get the plus. So positive 12 cos T. The last one is negative 12 sine T. Okay, this is your cross product. Okay, cross product. Then we want to find for the magnitude of the cross product. Okay, magnitude. So 16 square. What is 16 square?
256.
56.
56.
56. Plus
144.
144 cos square T plus
144.
144 sine square T. Okay. So which is equals to
144.
2, 6. plus 1/4, right? Which is 400. 400 that means 5 feet. Then put the value, okay, to the formula. Okay, magnitude is 20. 20 divided by magnitude of r prime. Magnitude of r prime is 5, so 5 cubed. So 20 over 125, which is 4 over 25. Okay, so for question number 1 or 2, actually it doesn't matter whether you want to use the first or the second formula. Okay. This one is just let you experience, okay, to use the 2 different formulas to get the answer. Any question for number 2? No questions? Proceed to number 3. Okay, number 3. This one, you have to use first one or second one? The second formula. Okay, for number 3, we use the second formula. Okay, but this one, you have only 2 component functions. For the cross product, we need 3 component functions. So how to get a cross product? You insert a 0. When you compute for the cross product, you insert the 0 for the component function of k. Okay, number 3. E and Q. Find the curvature. Okay, so we find for the R prime, R magnitude, R prime magnitude, R double prime. Cross product. And magnitude of cross product. R prime. R prime is 1 and 4t. So the magnitude is 1 plus 16 t squared. Okay, so this one we can write in 1 plus 16 t squared to the power of half. Okay, then R double prime. R double prime 0 and 4, and the cross product you have I, J, K. Okay, you must have 3 common functions in order for you to do the cross product. So R prime is 1, 40, 0. R double prime is 0, 4, 0. Okay, insert the 0 component function for K. What is the component function of I?
0.
0. 0, I, and component function of J?
0.
0 as well. Component function of K? 4. Okay, so meaning that this is 0, 0, 4, right? Okay. So magnitude, the same, 0 plus 0 plus 16 is 2. You get the 16, which is 4. Curvature is that's made 4 over this one to the power of 3. This one to the power of 3. That's made 3 over 2. Okay, because you need to give the power of 3 for this one. Power of 3. So you have 3 over 2. So this one is much simpler if you compute using the first formula. Okay, any questions or curvature? Okay, so I give a summary here for the curvature. Okay, curvature. Okay, you have curvature on the plane curve and curvature for the space curve. For plane curve, there are positive and negative sign for curvature, but for the space curve, it will always be non-negative. Okay, non-negative. And the curvature, it refers to the magnitude of the rate of change of the direction for the tangent vector. Okay, the faster is the tangent vector change direction, the higher is the curvature. So if you have 2 points on the curve, the one with higher curvature, it must be change the direction more faster than the other one. Okay, if it has a higher curvature. Okay, so the one with the smaller oscillating circle, it has higher curvature. Okay, that is curvature. Okay, binomial vector. This one is simpler. Okay, binomial vector is perpendicular to tangent and normal vector. Okay, just like the cross product that you have learned. If you have A, okay, look at this one, A cross B. A cross B, it means it will give you a C, right, which is perpendicular to the A and B. Okay, so same goes to this one, the binomial vector. You have P, you have T, you have N. So when T cross N, you get a B. Okay, so whether the B points upwards or downwards, it depends on which one cross to which. Okay, so this one you have to understand the right-hand thumb rule. Have you heard about the right-hand thumb rule? Did you apply in your? Yes, I think you know the right-hand thumb rule. So in this direction, okay, it points upward. Right, okay. Right hand thumb rule, that means you have to use your right hand. Okay, right hand thumb rule. All these fingers, it points to this direction. Okay, that's means this direction, right? Then you get the upward. So if you look at this direction means T goes to N or N goes to T. T goes to N. So this is the direction that follows the right hand thumb rule. So in this direction, that means your B points upward. So that's why T cross N, you get P. If N cross T, you get the negative B. You point downwards. See? If N cross T, that means in this direction, right? How to get in this direction? It must be this direction. N to, okay, N to T. Your N is here, your T is here. So in this direction, this one, your B points downwards. Okay, you get a negative B. Okay, so T cross N, you get a B. T and B. All Malaysians know what is T and B, yeah? Okay, T cross N, you get a B. Okay. T cross N, you get a B. So this one, actually this one, this is similar to the how you tighten or loosen the screw, or you tighten or loosen the cap. If you have a container, you want to loosen the container of the cap of the container. You use the same way, just like this one. Okay, this one actually, if I don't use the right hand thumb rule to check like this, I can just use this way. Okay, T to N, that means this one it goes up. This one it goes down. Container. Let's say a container. The cap. Okay, this one. The container. The container. When you this direction, it goes down. Your pencil goes down. If you turn in this direction, it goes up, right? So imagine this one, if your T and N lines on a plane. It's a plane. So T goes to N, that means this direction, right? This direction. So it goes up. You are opening something, it goes up. And the T, that means in this direction. And the T, it goes down. So this one, N and T, we will just use because T goes to N, you can go 90 degree or 200 and much. 270. 270, right? So it must go follow the 90-degree direction. You don't go to use this direction, T cross N. No, not this direction. You use the 90-degree directions. Okay, so let's say, I have I, J, K now. I want to test you whether you understand the direction or not. What is K cross J? What is K cross J?
J.
I.
I or negative 9? Above? Negative 5. K to J. K to J, it goes to that direction. Right? K to J, it goes in negative 5. Because I is in this direction, that means negative 5 in that direction. Okay, what is K cross I? K cross I. Positive J. What is J cross I?
K.
J cross I. Right? Negative K. Okay, so if you understand the right-hand thumb rule, okay, you should know what is B cross N. What is T cross B? What is T cross N? Okay. Are you still here this Thursday? Are you still in campus this Thursday? Okay, so I leave this the last few topics. We are leaving on the last class of this course. Okay, so I see you on Thursday.